All right, today you get a BC lesson. Exciting. Today's lesson is on partial fractions, mixed integration. And so I want you to look, today's about looking at fractions and figuring out how am I going to integrate this. The first thing you should always look at, I think, is take the derivative of the denominator. Does it match the numerator in terms of like terms? No. And then I think of like, well, should I complete the square? What should I do? And here's the answer. If this is factorable, you can do this by doing partial fractions. So this is what I'm going to do. I'm going to factor it. There it is. So -3 and -4 factor. They're going to separate into two fractions. One fraction is going to have x minus 3. And the other fraction is going to have x minus 4. So we're kind of working backwards. Usually we have unlike denominators and I multiply to put them together as one fraction. We're going the other direction. We're separating it into two fractions by factoring. And I'm trying to find what these values are. And I'm going to call them A and B to help us separate this into two fractions and then integrate each one separately. So at this step, I'm going to multiply by x minus 4 top and bottom. And I'm going to multiply by x minus 3 top and bottom. And notice I have like denominators then. And I'm going to take the numerator only and make it equal to the numerator. At this step we're going to use the zeros to help us out. So the first 0 I see is positive 4 makes this 0. So when x equals 4, so when x equals 4, this is 0, and it leaves me with b, x minus 3 equals 1 to be able to solve. And remember, x is 4, so this number here is going to be a 4. So put in 4 for x, that's the 0, 4 for x, and then solve it. So 4 take away 3 is 1b. So I already found one fraction. So one fraction here is 1 over x minus 4. The second one, I'm going to take the other 0. So the other 0 is positive 3. So let x equal positive 3. So 3 take away 4 is negative 1. 3 take away 3, that's 0, and that's equal to 1. So divide by negative 1, and a is equal to negative 1. So we're going to subtract, and the other one is going to be 1 over x minus 3. So that's called partial fractions that we did. We can do it. And then when you integrate, now take the derivative of the bottom, it equals the top. That's just a logarithm. Again, the derivative of the bottom matches the top. That's just a logarithm. And then plus c. All right, let's try it again. I really think the key is seeing if the denominator is factorable to look at it as a technique. So if this is factorable, I'm just going to rewrite. I'm going to come back for the answer in a moment. I'm going to rewrite the fraction here. If this is factorable, what are the two factors here? Well, one's going to be negative 3. And the other is negative or positive 1. So negative 3 times 1, negative 3 plus 1, those are my factors. And then one's going to be a and one's going to be b. So we're going to let 5x take away 3 equal. Now to create common denominators, I'm going to multiply this by x plus 1. And I'm going to multiply this by x minus 3. And I only look at the numerators then. And now I focus on the zeros. So if x equals -1, then what am I left with? So -5 take away 3 is -8. A -1 take away 3 is -4b. And then when I divide, b is equal to 2 when I divide it. So now you have one fraction to work with. So 1 is 2 over, you can put that right here. As soon as I have it, I'll put it right in. So b is 2, and that's over x plus 1. Next, what's the other 0 that I'm going to have? And that would be +3. If I plug in +3, I get 15, take away 3. If I get common denominators here and multiply by, oh no, what am I doing? I'm right here, sorry. Plug in +3, and 3 plus 1 is 4a. And then of course 3 take away 3 means that's 0. Alright, solve for a here, divide by 4. And a is equal to 3. So that's our second fraction. So plus 3, now a is over x minus 3. So I'm going to continue down here. I want you to notice that the derivative of the bottom is 1, so you put a 2 in front. So it's 2 ln x plus 1. The derivative of the bottom is 1, so a 3 in front. And then plus c. Right? Not too bad. Example number 3, turn the page. And before we get too cute in terms of doing partial fractions, we need to see if the derivative of the bottom matches the top before we do anything else. So we have to focus on these lookalikes to make sure we're going in the right direction. So the derivative of x squared and -2x is 2x minus 2. This is just a logarithm, and use the denominator. Done. Here, notice the degree on top is bigger. So step 1 is to divide. I have to do long division. So if the degrees were the same, or one bigger on top, or even two bigger on top, then you divide to simplify it. So that's going to be x and then multiply. Be careful. I could have drawn it a little better for like terms. So x cubed. There's no x squared. So no x squared subtract x squared is negative x squared. And negative x subtract negative 2x. When you subtract a negative, you're adding 2. So -1 plus 2. And then bring down the 2. We're going to do it again. And negative x squared divided by x squared is -1. Multiply. And then the remainder. So these are done. X subtract negative x is 2x. And these are done. So that's the remainder. So I come back here. So first of all, we started with x minus 1. And then we have a fraction, which is 2x over x squared plus x minus 2. So I already know the integration for x and -1. This here, the derivative of the bottom is not going to match the top. So I'm going to use partial fractions to be able to do this. So I'm going to factor this out. Where am I going? I'm going to do it right here. So the two factors are x plus 2 and x minus 1. And we'll call one a and one b. Really, it's just the numerator that I have to worry about. So to get common denominators, I'm going to multiply by x minus 1. Here, I'm going to multiply by x plus 2 to get common denominators. And then again, I'm only going to focus on the numerator and make it equal to 2x. Next, I focus on the zeros. So what makes this 0 is x equals 1. So that leaves me with 3b equaling 2. So b is equal to 2 over 3. Make sure that's right. And then I focus on the other 0, which is negative 2. So when x is negative 2, we got negative 2, negative 1, that's negative 3a, is equal to negative 4. So if I divide that, it's positive 4/3. And now I'm going to sneak over here because I got room over here to the left. So here I am over here. I'm going to sneak over here. So I'm going to integrate. We have x minus 1. We now have two fractions. So a, we just found, was 4/3. So there's 4/3. I'm going to write it like that. And then the denominator for a is x plus 2. The second one is 2/3 for b. And then that's over x minus 1. All right. And now we can integrate this. So the integration of x is x squared divided by 2. The integration of negative 1 is negative x. These are logarithms. So the derivative of the denominator is 3, but it was a 4. So it needs a 3/4. I just distributed for fun. So, it was a 4 and it became a 3. It's the other way around. Let's see if I do this one right. So the derivative of the bottom is 3. It was a 2, it became a 3. Or you can just factor out a 2/3 in front and just do the logarithm there too. And that's it. What a great little question. So we started with long division, and then we did partial fractions, and then we put that beautiful mess all together and integrated it. All right. Integrate these look-alike ones so you don't get confused when it's a fraction what direction to go. So if I look here, the derivative of the bottom does not match the top. It's also not factorable in the bottom. This one is tangent. This is arc tangent. The square root of x squared is u, and the square root of 1 is a. And so it's u over a, or just x, plus c. Here, the derivative of the bottom is 1. It matches. That's a logarithm. Don't forget the candy bars. For c, the derivative of the bottom is 2x. It's also a logarithm. I need a 1/2 in front. And then d, write this calculus friendly. So the derivative of the bottom is not going to work. It's not in the form of arctangent. Instead, I'm going to write it calculus friendly. Oops, 1 plus x to the negative 2. The derivative of this is 1, which is there already. So all I have to do is add 1 to the exponent and then divide and then plus c. That takes practice, right? To see the different forms and know what direction to go. Remember, we talked about how integration, like an art form, of solving a puzzle, right? Like math, this is what math people love, right? To try to figure out how to make it work. All right, integrate the following two lookalikes. So this is 1 over x and then ln x to the negative 1. Now, when I integrate this, it'll give me 0. So this is what's really happening. Let me rewrite this. 1 over x. Let me write it this way. So I'm going to rewrite 1 over x in the numerator so you can really see it. So if I write it this way, 1 over x in the numerator, the derivative of the bottom matches the top, This is a logarithm logarithm plus c. So when the derivative of the bottom matches the top, it's a logarithm. This is a logarithm logarithm plus c. It'd be a good rock group name, right? Logarithm logarithm. B, this is the one I was going to do. This is 1 over x and then ln x. Think of it as ln x to the 1. The derivative is the hook. So that's just ln x, add 1 to the exponent and divide. Alright, a lot to process. I'm proud of you anyways. Mr. G Math over and out. Until next time, we'll do the assignment together and we'll keep practicing and learning.